In this video, I'm going to talk about factoring completely, which means that we aren't going to do just the basic factoring. There's another additional step that needs to be done. For instance, if we have a problem that looks like this, 2x squared plus 10x plus 12, you may or may not notice right away that all of these numbers here, the coefficients, all have a greatest common factor of 2. So there are two things that could be done with this problem. First of all, I could factor a 2 out right away, and then what I have left is x squared plus 5x plus 6. If I distributed this back through, I would end up with the original. Now, I can go through and factor that right away. So I would go through and make my generic rectangle. I'd have my x squared and the 6. Diamond problem, multiply these two together to go up top, and I get 6x squared. Middle term goes in the bottom of 5x. That would end up being 3x and 2x, which I place in the open boxes, and I get x and 2 and 3. So this problem in blue would now be written as 2, and what was left here is now written as x plus 3 and x plus 2. That is now factored completely. A second thing that could be done with this problem. Let's say right away you were working on this and you did not realize that there was a greatest common factor. So we're looking at this. Here's the problem that happens. I put my 2x squared here in the 12. My diamond problem then becomes a 24x squared, and the bottom is 10x. So now thinking of the two things that can go on the sides that multiply to 24 but add to 10, 6x and 4x. Taking out my greatest common factor from these two, I get 2x right here, meaning that is an x on the bottom. Over here, I'm going to get also a 2, because 2x times 2 will give me my 4x. And up top here, I would get 6, because x times 6 will give me my 6x. These two multiply to give me the 12, so everything worked out. So I end up getting 2x plus 6 times x plus 2. Here's where the problem comes in. Let's say, for instance, if I do the exact same things I just did, however, instead of the 4x being there and the 6x being in that box, I would switch those up. And if I follow the exact same procedure, I now get 2x right here, x on the bottom. This is now a 3, because 2x times 3 gives me 6x. And x times 4 will give me the 4x. But these still multiply to 12, so I still followed all the correct work, but now my factors are 2x plus 4 and x plus 3. Those are different. So if this is the case, what I can still do to get the correct answer is you may notice that this part right here still has that greatest common factor of 2. Same with this one. I still have a greatest common factor of 2 that I could take out of both of those. So working with the top one, if I would take a 2 out, I would then have x plus 3 times x plus 2. This factors into that, which is what we had initially before. And if I work on this one, if I take a 2 out of that factor, I would get 2, and I would have x plus 2 left and x plus 3. And now you can see that both of these, I have the x plus 3 factor, I have the x plus 2 factor, and I have a 2 on the outside. So both ways work. If you do not realize the greatest common factor right away, you can still factor it out at the end. But these answers here are not completely factored and are therefore wrong. We need to make sure that we are factoring everything out and getting that as our answer. A second problem that could happen with this, if I had a trinomial that looked like this, I can't even factor that right now. I can't make my generic rectangle because I have an x cubed, and we have never worked with something like that before. However, you may notice that there is an x cubed, x squared, and an x, which means I can take out a greatest common factor of an x on this problem. You also may notice that 3, 15, and 18 all have a greatest common factor of 3, so I actually can take out a 3x from each. And what I would have left then is x squared plus 5x plus 6, which is just like the last problem. And now I would go through and factor this the same way we did previously. So my final answer for this one would be 3x, and then in parentheses I would have an x plus 2, and another set of parentheses, an x plus 3. And that would be completely factored. So for this particular case, we cannot even factor it until we take out our greatest common factor of 3x.